This question says, when two magnets each of pole strength M and L are placed such that their axes are inclined to each other at an angle of 60 degrees with north pole of one touching the south pole of other, the resultant magnetic moment of the combination is. So here what is happening, we have a magnetic magnet of magnetic moment M. Let's say this is south pole and this is north pole. So magnetic field, magnetic moment direction is south to north. This is the direction. Now they're inclined at 60 degrees such that south pole of the one touches the north pole of other. So I'll say the next magnet is something like this. This is north pole and this is south pole. Now the magnetic moment is M in this direction. So this is theta. So if I want to find the resultant of the two, I can shift this magnetic moment in this direction. Then what will happen? Both the poles will be aligned to each other. I'm shifting this here. Now this angle would be, we know this is theta, so this will be how much? Pi minus theta. Now net magnetic moment in that case would be M equal to under root of M1 square, that is M square, plus M2 square, that is M square, because each magnetic moment of each magnet is M, plus 2ab cos theta, that is 2m into m is m square cos of pi minus theta. Theta is how much? 60 degrees. 60 degrees is pi by 3, or in angles 180 minus 60. So that is under root of m square plus m square is 2m square plus 2m square into cos 120. Cos 120 is how much? Minus 1. So that becomes under root of cos 120 is minus 1 by 2. So 2m square into minus 1 by 2. So that will give me m. So the resultant magnetic moment of this combination is equal to magnetic moment of one magnet. And what is that? M, which is given by m into L. So the answer for this question is option A, m into L. Hope you could follow this. Thank you very much.